Good morning, students. Up to now, we see topic specific heat capacity. Okay, so the definition of specific heat capacity tells us that the amount of heat required to raise temperature of a substance by 1 degree Celsius. That heat is called specific heat. Now, today we have to see the concept of heat exchange. Okay, so for that we have to consider one isolated system. Okay, in that system we have to consider two bodies, one is hot object and one is cold object. Okay, so this hot object and cold object are in contact with each other. Okay, but their surrounding environment is isolated from the other environment. Look at here, isolated means what? Only whatever the exchange maybe takes place, that will be in these two bodies only. Means these two bodies are apart from all other things. Only these two bodies are in contact. Okay, whatever the lose or gain takes place in between here, that only in two bodies. Okay, means influence of environment is nothing present in this system. Okay, so such a system is called isolated system. Isolated means separate. Okay, so in isolated system, these two bodies, hot object and cold object, are in contact with each other. Okay, so we call it box of heat exchange material. This diagram you have to remember. So here what happened, we know, if we kept two bodies in contact, one hot object and one is cold object, then we know heat transformation is takes place in this condition. Okay, so as like water flow from higher height to lower height, such a way that heat flow is also takes place. Okay, exchange of heat is takes place in this case. Okay, so how this exchange of heat takes place? So this exchange of heat takes place from hot object to cold object. What? Hot object to cold object, such a way that transformation of heat is takes place. Now we consider this system is isolated. Okay, hot object and cold object are in isolated system. Means whatever the heat energy lose by this hot object, that much heat energy will gain this cold object. Okay, now suppose we consider two objects. Okay, one is hot and one is cold. Suppose one is at 30 degrees Celsius and one is at, we can say, 0 degrees Celsius. From now we brought them in contact with each other, then we can say that heat exchange will be takes place in that condition. Now the question will be arise, how much time this exchange of heat takes place in that condition. Okay, so this heat exchange takes place up to that much time when temperature of both objects are become equal. Okay, what happened, we know water also flow from higher height to lower height. Up to how much time? When their heights become equal. Same way, by using that analogy here, we can say that this heat exchange takes place up to that much time when their temperature becomes equal. Okay, now we consider one at 30 degrees Celsius and one at 0 degrees Celsius. So heat exchange there, no doubt about that, from hot object to cold object. Okay, so hot object at 30 degrees Celsius and cold object at 0 degrees Celsius. So heat transformation takes place from hot to cold object. So what happened due to the exchange of heat energy? Temperature of hot object decreases. Okay, and simultaneously that heat energy absorbed by this cold object, due to that its temperature start to increase. Okay, so hot object's temperature decreases and cold object temperature increases. So that process is continuous till temperature of both objects become equal. Means at 15 degrees Celsius, what happened? Both now have equal temperatures. So when temperature of both objects become equal, at that time this transformation of heat stops. Okay, so we have to remember here transformation of heat also takes place from hot object to cold object, and up to how much time this transformation of heat takes place. So that also we have to remember that much time up to their temperature does not become equal. Okay, as their temperature become equal, then this transformation of heat from hot object to cold object stops. Okay, so that is why we have to consider here one isolated system. Isolated means what? Apart from the environment. Okay, no influence of other objects present here, only these two bodies are in contact with each other. So whatever the heat lost by this hot object, that much heat energy gained by this cold object, because this is isolated system. That is the meaning of isolated system. So what happen in that case? Whatever the heat energy lost by the hot object. Okay, so what happen, one hot and one cold object, when we are brought them in contact with each other, then what happen, heat exchange takes place from hot object to cold object. Okay, so in this isolated system, what happen, whatever the heat energy lost by hot object, that must be equal to heat energy gained by cold object. Heat energy gained by the cold object. Okay, so whatever the heat energy this hot object lose, that all heat energy absorbed by this cold object, because this is isolated system and only these two bodies are in contact with each other. Okay, so whatever the change takes place here, that will be corresponding to only these two objects. So here what happens, simply hot object will lose its heat energy and cold object will absorb that heat energy. So such a way that this principle is followed in this isolated system. Hot heat energy lost by hot object will be equal to heat energy gained by the cold object. Okay, that is the principle of heat exchange. What? Principle of heat exchange, that we have to remember. Okay, so now next topic we have to see, that is the specific heat capacity. We have to calculate specific heat capacity by using mixture method and calorimeter. Okay, now next topic we have to see, that is the measure of specific heat capacity mixing method, by mixing method and using calorimeter. Okay, so now here we have to calculate here what? Specific heat capacity of some hot object. Okay, by using mixture method. Okay, mixing method and calorimeter. Okay, so first of all we have to know what is calorimeter. Calorimeter is an instrument, like not exact as like this, but for our convenience we use such a way. Okay, here water is a present. Okay, water is present. Okay, so what we have to do here, we have to just put a hot object in this water that present in calorimeter. Okay, here in middle position water is there, this is the body of calorimeter, in middle water is there, and just we have to put hot solid object in this water. So by using this all, we can calculate the specific heat capacity of the object. So here we have to consider a one hot solid object. Okay, and we have to measure the specific heat capacity of that hot solid object. So first of all, if we put, look at here, we draw a diagram. We already draw this diagram. Suppose this is calorimeter. Okay, so if we place, okay, this water is cold, this is not hot water. Okay, if we place any hot solid in this water, then what happen? We know heat exchange will be takes place there. That is no doubt about that. Okay, so heat exchange takes place from hot object to what? This water first. Okay, some heat will absorb this water and the remaining some heat absorbed by this body of calorimeter. Okay, body of this calorimeter. So such a way that whatever the heat lose by the hot object when we place in water of this calorimeter, that will be gained by two ways. First of all, by this cold water, and second is by this calorimeter. Okay, so we can say that heat energy lost by hot solid will be equal to heat energy gained by calorimeter, that is the first, and heat energy gained by water in calorimeter. Okay, what? Heat energy gained by water in calorimeter. Now, first of all, heat energy lost by solid object that we call Q, capital Q. So now this formula we studied yesterday lecture. Okay, so we know heat energy lost by any object if temperature increases or decreases, that is given by mass of that solid into specific heat capacity of that solid into change in temperature. So this formula, M into C into delta T. Okay, this formula we are already studied yesterday, that is this formula. Okay, when we place any hot object in this water, then what happen? It will lose its heat energy. How much heat energy that water can lose? So that is given by this formula. What heat energy lost by hot solid will be equal to heat energy gained by calorimeter plus heat energy gained by water in calorimeter. So heat energy lost by hot solid will be equal to mass of the solid N, specific heat capacity of solid, that is the C, and change in temperature, that is the delta T. So this is the heat energy lost by hot object, that is we call Q. Now second, heat energy gained by water. Okay, so this is the first what? Heat energy lost by hot solid. Now that lose heat energy absorb these two objects. First is what? Energy, some absorbed by calorimeter and some by water present in calorimeter. So first of all we have to calculate heat energy gained by the water in calorimeter, that we call Q1. Okay, so we know that heat energy gained by any object is again given by what? Mass of water into specific heat capacity of water into change in temperature. Okay, what happened initially? Water is cold. Due to the absorb of heat energy, its temperature will be increased. So that change in temperature we have to take here. So by using same formula, we can calculate the heat energy gained by the water, that is the Q1, mass of water into specific heat capacity of water into change in temperature. Now third, we have to calculate heat energy gained by calorimeter, that we call Q2. Okay, so this heat energy by this calorimeter, okay, this body of calorimeter, whatever the heat absorbed by this calorimeter is given by mass of calorimeter into specific heat capacity of calorimeter into change in temperature, MC delta T. This formula we have to use when somewhat object gain heat energy or lose its energy. Okay, so MC delta T, M is mass of object, C is specific heat capacity, and delta T is change in temperature of that object. So by using this formula we can calculate heat gain or lose. Okay, so simply here when we place hot object in the water of calorimeter, then what happen? Heat energy lost by this solid, hot solid object. Where did that heat goes? So that heat absorbed by two objects. First of all this water and second is calorimeter. So that we have to write in the formulas only. Okay. So we can say that heat energy lost by hot object will be heat energy gained by calorimeter plus heat energy gained by the water in calorimeter. So just we have to separately write this heat energy, how much heat energy lost by hot object, how much energy gained by water, and how much energy gained by calorimeter. So by using that, now heat energy lost by hot solid, what we call it? Q. So we write here Q, that will be equal to what? Heat energy gained by, this is what? Q will be equal to heat energy gained by calorimeter. Okay, that we call what? Heat energy gained by calorimeter. So that we call generally Q2 plus heat energy gained by water, we call here Q1. So we can say that this Q, that is the heat energy lost by the hot solid, will be equal to heat energy gained by the water in calorimeter plus heat energy gained by the calorimeter. So here we can calculate the specific heat capacity of this hot solid. How? By, if we know the specific heat capacity of this water that is present inside the calorimeter and specific heat capacity of this calorimeter. If we know the specific heat capacity of these two objects, that is the water and calorimeter, then we can easily calculate the specific heat capacity of this solid object. Okay, so such a way that we can calculate the specific heat capacity by using this mixing method and calorimeter. Okay, so actually this is the last topic of this chapter. Now this chapter is finished here. Okay, now in tomorrow's lecture we see problem based on this topic, that is the measurement of specific heat capacity by mixing method and use of calorimeter. Okay, so if you have any problem in this topic, then please ask me. Okay, actually this formula we are already studied in the previous topic, that is the specific heat capacity. Okay, so in that topic we have to see heat gain or loss can be calculated by using this formula, m into c into delta T, where c is a specific heat capacity, delta T is a change in temperature, and m is a mass of the object. Okay, so such a way that we can calculate the specific heat of any object by using this concept, that is the calorimeter. So now from tomorrow we will start problems based on this chapter. Okay, if you have any problem regarding to this chapter, then please ask me. Okay, so we will see the remaining part in tomorrow's lecture. Thank you.